Okay, so the first part, I think just about everybody did really well on this. The most volume was G, because it's the biggest. The least volume was E, because it's the smallest. The most mass is C, because it's got the most stuff in it. The least mass is F, because it's got the least stuff in it. Most weight and least weight are the same as these, so it's just going to be C and F again. The one with the most mass is the heaviest. Wait, that's not the right answer. C doesn't have the most. That should be B. So there's definitely more stuff in this one than there is in that one. I'm sorry. Now denseness, C is the most crowded, so it's the most dense. And the least dense is A. It's the least crowded. And what I was saying before is this has got the most stuff, so it's the heaviest. It has the most weight. And that has the least amount of stuff, so it's the lightest. Those should be really straightforward. If you miss those, you're not studying, I would say. Down here, these get a little trickier. Anybody who missed stuff on the first page usually missed some of these. An object's size increases, but the amount of stuff in it remains the same. So I would recommend, if you're having trouble with these, do a little diagram. Make an object and make its size increase, and then draw some stuff in it, and then draw the same stuff in it, and then answer the questions. So mass, that's the amount of stuff in it. That stays the same. Volume is the size. That gets bigger. Density is how crowded it is. It gets less crowded. And weight is the same as mass. It's going to stay the same weight even though it got bigger because it's got the same amount of stuff. Number 13 through 16, the particles become less crowded, but the size doesn't change. So here we go. I'm going to try to do two things the same size. And the particles become less crowded. So I'll draw this and I'll make them pretty crowded. And the only way to make them less crowded is to put fewer in there. So the mass has to decrease because mass is the amount of stuff. Volume is the size, so that's the same. Density is crowdedness, so less crowded, less dense. And weight is going to be whatever mass was. So this is going to be lighter. Any questions about that? Didn't think so, but if you have any, please ask. Okay, the top on the retake, this might ask you what happens if you heat up the molecules. I'm gonna ask the same questions, but it's either going to be what if you heat them up or what if you slow them down. So cooling, they get slower. I'm just going to try to answer this with as few words as possible. When the jar is cooled, what happens to the pressure? Less, decreases. And what's creating the pressure? This is the one where people didn't explain what I wanted. It's the molecules pushing. And you could say they're pushing each other. You could say they're pushing the sides of the jar. I kind of like sides of the jar better. Pushing the sides of the jar. But you could just have this. It's the molecules pushing. If you just said molecules, no. If you just said pushing and you didn't say what was pushing, no. I wouldn't give you anything for just molecules. I might give you half a point for pushing. But we don't really know if it's person pushing or what. Okay. All right, now this next part, a balloon. So here the balloon's heating up, but it could be cooling down, and it would just be the opposite answers. So if you heat up a balloon, here's a, it says no air can escape. The balloon is stretch. So it can grow and shrink. Guess what I meant to type there? I meant to say stretchy. Stretchy. It's stretchy so it can grow and shrink. Someone heats up the balloon. So if you have a balloon like this with some molecules inside, and then you heat it up, it's going to get bigger. And the reason is because the molecules are going to move faster. And they're going to bounce around more and push against the walls harder, so it spreads out. So the volume's going to increase. The mass is going to not change because no air can enter or escape. The weight is not going to change because the mass doesn't change. The density If you have the same stuff, but now it's in a bigger space, it's going to be less crowded, so that's going to decrease. And if you have, and the pressure is what's making the balloon bigger, so that's increasing. So if you were cooling the balloon off, what would happen to volume? Anyone? If you have a balloon and you make it really cold, you put it in the freezer, what's going to happen to the volume? Decrease. And what's going to happen to the overall mass of the balloon? No. Not unless, only if it leaks, but this is a non-leaky balloon. It's a stretchy balloon, but it's not a leaky balloon. So what's happening to the mass? No change. And what would happen to the weight of the balloon if you put it in the freezer? Weight is the same as which other one? Which of these other three, density, mass, or volume, which one tells you what's happening to weight? Mass. And mass is the stuff in it. And if no air can leave and no air can enter, then the mass has to be the same and so does the weight. So if the mass doesn't change, the weight doesn't change, unless you take it to the moon, which we're not doing. And then the next, if you cool this balloon off and it gets smaller and it has the same amount of mass, what's going to happen to the density? Increase, decrease, or no change? What? Is it going to be more crowded inside or less crowded? It's going to be going from, here's the balloon, like this, to a smaller balloon like that, with all that stuff still in it. Is that getting more crowded or less crowded? It's getting more crowded. So if you were cooling this, if you put it in the freezer, the balloon's going to decrease volume, keep the same mass, keep the same weight, increase density. And what about the pressure in the balloon? Is this going to have more pressure or less? Less. I mean, the whole reason it's shrinking is because there's less pressure. If there were a lot of pressure, it would be pushing the sides out. So all the answers would be opposite except for which ones. If I change this to cooling, 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 how many of these would not change? How many answers would be the same? 2. It would be these two. Doesn't matter whether you heat it or cool it, the mass and weight aren't going to change. Okay, then the last part. You squeeze a bottle. It gets hotter. Why? You push the molecules, speeding them up. Now, if all you said was you push the molecules, I would give you points for that. Some people, might have been a person or two who said, you give the molecules energy, and I think I might have given you credit for that too. But you're pushing them. When you push them, they go faster, and they get energy. Number 27, what happens to the temperature when you release it? It gets cooler. And the bonus, why does it get cooler? It's just the opposite of this. Instead of you pushing the molecules push you. Giving you their energy. So they lose it, which cools them down. So they slow down and cool down. All right. If you take this again, it'll be a different set of these, but it'll be these same questions. It'll be some different kinds of questions down here, but it'll be basically the question will tell you what's happening with 2 of these, and then you have to figure out the other 2. And this may say cool down or heat it up. This may say heating or cooling. This may say squeezing or releasing. And this may say releasing or squeezing.